Hi, welcome to the Interop. This is the show which explores the decentralized economic networks that make up the interchain. My name is Sébastien Couture, and today we've got a bit of a special treat for you. I've got my buddy Richard Caetano here, who's going to be guest co-hosting this episode, and we have our guest Jakub Wojciechowski, who is CEO of RedStone. So actually, this is interesting because we met last week at DevConnect in Amsterdam, and it was like a total chance meeting, and we ended up having dinner, and we got into these deep conversations about crypto and data availability and modular blockchains and stuff like that. And you guys are doing some interesting stuff also with Arweave, and I was like, okay, I want to dive into this. And Richard, being someone who I know and trust and who's building on Arweave, I thought this is the best combination to have here on the show. So thanks to the two of you for joining me.
Thanks for having us. Yeah, our pleasure.
So I mean, maybe just Richard, perhaps just give our listeners a bit of background on yourself and what you're doing right now.
So been in the blockchain crypto world for quite some time, since nearly the beginning, and that's how I kind of got to know you, Seb, early on. And currently we're building our company Akord. We're building this privacy layer on top of Arweave, and trying to build a new set of storage tools based on Web3 concepts, where Arweave as a permanent storage layer is providing a bulk of those services. And we're also working with RedStone quite a bit on the development of our protocols and the smart contracts that run those protocols. And that's, I guess, sort of how we all kind of converged together in Amsterdam.
Yeah, I mean, Richard's a Bitcoin OG. He's been around since even before I have. And we actually co-founded a company together a couple of years ago.
I forgot to mention that part.
Those who listen to Epicenter, will remember Stratum. And so Richard was the CEO of Stratum, and we've come through that intact, and so I'm happy to be doing this with you. And Jakub, thanks for coming on. Can you tell us a bit about your background and how you got into this space?
Sure. So thanks for having me. So I'm a computer scientist by trade and education. Then I used to work in traditional finance, like fintech, insurance tech, etc. And in 2016, we decided to look for something new. Me and my wife, we moved to London. I was looking to explore new technologies, and that's how I discovered blockchain. Participated in the very first blockchain hackathon, lucky enough to be a winner. That was the year when the Ethereum came out, and then I co-founded a startup. It was called Alice. It was a philanthropic startup, and then obviously it's not the greatest business you can imagine in terms of the commercial potential. So we slowly started to wind down the startup when the COVID struck, and in the meantime I was smart contract auditor and participated in multiple hackathons. And that's how I discovered more and more issues with the current implementation of the oracles, and decided to do something about it, joining the Arweave first batch incubator program. Hello.
Yeah, that's interesting. So so you guys are both doing stuff in the Arweave ecosystem. Richard, you're building a company in the Arweave ecosystem, and so are you, Jakub. So this is an ecosystem that I don't have a whole lot of visibility on. We interviewed Sam on Epicenter, and I thought, okay, this is a cool data storage play, but they have a really, I think, unique vision compared to some of the other platforms that I know of, like IPFS and Skynet and these sorts of things. What's unique about the Arweave ecosystem and about the Arweave technology that most people perhaps don't really grasp or understand? And maybe both of you can give a shot at that.
Okay, so I can start. So what I really like about the ecosystem is is very technical. Like in a lot of crypto universe, you get different kind of people. Some are there for quick money, like trying to shield some crazy coins, and I've never came across anyone like that in Arweave. Everything is like very technical, engineering focused, super friendly, cooperative. So like for me, it's an amazing place for builders to try out the ideas, etc. So yeah, the cultural aspect is like super important for me as well.
Yeah, I think that one of the I think one of the important things that Arweave brings is this, this idea of permanence, and I think it's quite timely of a solution. So I think when I discovered Arweave, shortly after, it was like an NFT craze, and all these NFTs, and people were spending tens of thousands of dollars for these images, and they were stored on temporary protocols such as IPFS or or even worse, some centralized solutions. And so having the ability to write those bits out onto a chain and then being able to incentivize miners to to protect that data into the future, I thought that was quite novel, and it was really a 0 to 1 that I haven't seen before. And kind of extending that observation outward more, one of the things that I saw is just it's really the opening door for what we call Web3, right? Which is complete ownership, being able to bypass centralized forms of control and restricted access to certain types of media and things like that. Arweave kind of blows past all of that. So yeah, and then there are also these like kind of like political and social kind of like reasons that Arweave exists, which are in terms like preventing censorship. And so one of the interesting projects that we see right now is someone or a team built a bot that is recording like very sensitive documents in the Ukraine Russian aggression, and making sure that they're able to store those documents so that later on historians can kind of filter through it and like find different things about it. So I don't know. I find on different layers, different levels, like Arweave is quite an interesting project, and that's what like sold us. That's what got us really interested in it.
Yeah, that's interesting. Yeah, and I think one of the things also that, and we'll talk about this here, that Arweave sort of innovates on is the smart contract paradigm. I think in Arweave, from what you guys have told me, is like totally different from what we know in Ethereum or Solana or the Cosmos ecosystem. And one of the things that I want to talk about today is this shift towards more modular blockchains where there's a data layer and smart contract execution happens like in a separate layer. And this is a trend that I think is happening more broadly in the ecosystem with projects like Celestia and like even Ethereum 2 moving towards that model. So yeah, I mean, I'd love to get into that and like get a deeper understanding of all this stuff. But first, I mean, maybe Kuba, for you, like, what made you want to spend your time on oracles? Because like if you look at the space, like there are multiple companies and projects building Oracle systems, like Chainlink, and there's a whole bunch of other ones. And so, where did you see in this space like a problem that really needed to be solved, and how is RedStone addressing that?
Totally. So it started out of my own frustration with the current level of Oracle. So I was participating in multiple hackathons, and often we got a really good idea, and you need some additional data, like the data about interest rates on chain or the liquidity of different pools, etc. It's like perfectly easy to grab from the off-chain environment, but if you try to consume that within a smart contracts, then you can encounter some issues. And I was really curious, like why the current incumbents with a lot of experience and definitely very mature technology cannot cover a range of different feeds. And definitely the most popular design pattern of providing data to smart contract is still through the on-chain storage, which solves a lot of issues with data availability, with the security of data transmissions, etc. But on the other hand, it's very expensive. So I think there was a moment when the cost side was actually really heavy, and it was like preventing the Oracle ecosystem to cover more and more assets or any interesting data feeds. And yeah, so I was trying to do something about it because, as you mentioned, Chainlink I think it's an amazing company. It's gotten a great reputation, but the problem that it solves right now was a problem of the blockchain ecosystem from like 3 or 4 years ago, when there was only like a few dozen of interesting tokens, blue chip tokens, and only Ethereum was a very dominant network. While at the moment we got like a Cambrian explosion of not only layer 1 networks that are EVM compatible, but also plenty of L2 networks, and obviously even thousands of interesting assets that you can query price of, not to mention other interesting indicators. So for me, the goal was to build a really scalable solution that can out of the box cater to any EVM compatible chain, and also to lower the data access cost to minimum. So we got a crazy idea of utilizing for storage a network that was designed to be a storage network. That's how we encounter Arweave, instead of utilizing a storage of EVM chains, when on that kind of an architecture, the storage is heavily penalized because you focus more on the throughput and you want to discourage people from extensive usage of input and output. So we use Arweave for storage, and we get a really innovative technology of passing data from Arweave or from within our nodes to any VM compatible chains. I can go deeper into the technical aspect if you're interested, but
Yeah, for sure. Yeah. But so you guys brand yourself as a cross-chain oracle. What does that really mean? And like, do you mean from that you're pulling data from different chains, or that you're able to provide data to different chains, or both? And how does that actually work compared to like this more traditional oracle design that you were talking about earlier?
Yes, I'm happy to take. So to answer it shortly, it's both, but it's not a pure marketing. I think a lot of oracles can say that they're cross-chain, because if there is new chain, then can spend like 3-4 months to integrate with that new chain and be compatible. In our case, if tomorrow there is a new EVM compatible chain, we can start serving data to that chain without any changes in our architecture. So because we do not touch the storage of the target chain, we do not need to integrate. So we are really focused on being interoperable, and yeah, it's actually a fact, let's say, deeply rooted in our architecture.
Okay. So what kind of data sources do you pull from? What's the kinds of data that we can get from RedStone?
So at the moment we got 60 data sources, but we are still like quite early, and it's also very easy to add new data sources. So we work with a few projects, and we got an open architecture. Code is fully open source, and then even can implement their own fetchers, connectors, adapters to external data sources. And in terms of the price feed that we currently cover, that obviously like crypto tokens, more than 1,000 tokens, and from other interesting price feeds we get currencies, a lot of currencies from, for example, the late of South America, which we get a lot of requests for that, and stock prices, commodities. What we are looking to are obviously the NFTs, which will be coming soon. We got the capacity with the low cost to cover a lot of the NFT prices, and also we'll be rolling quite soon a very customizable oracle, so anyone can specify in a user interface set of data feeds and then start pulling data. So yeah, our idea is to be as broad and as possible to truly utilize the low operating costs.
So I had a quick question, maybe a little bit to dive in a little bit deeper from your introduction with the Oracle service. So kind of the two aspects that I think that are kind of a relevant discussion to have around oracles is basically things like latency and gas costs, and how are you staking against that? Could you talk a little bit more about what you've seen different between like other chains and Arweave, and then also what were some of the challenges that you may have experienced in trying to solve those aspects? And if you want to describe those aspects a little bit further, that'd be great as well.
Mm-hmm. Okay, so trying to start from the beginning, the latency. So currently we offer in a stable way the price feeds refresh every 10 seconds. We've been experimenting with 1 second interval. It's quite fine, although some of the off-chain data sources are not as fast, so probably we need to better go locate our nodes for that. But I think it should be possible. In terms of gas costs, we got a hacky way of actually smuggling the messages, leveraging our user interaction. So we append the price feed in a special format, fully signed, so it could be cryptographically verified to a call data of a user transaction. And then every user that would like to execute the transaction within the context of that price carries the price feed, and then we extract it, verify the origin of a price feed, check at the protocol level where the protocol can trust a given source, and if everything is fine, if the timestamp is fine, the type of data is fine, if the creator of the data is also verified by a protocol, a user may access that price information. And all of that's written purely in a Solidity assembly to be as efficient as possible. And yeah, like in total, that the whole operation is about 10,000 gas costs, which is super cheap. So if you compare to the usual cost of the referential price contract data access, which is about like 20 or 30,000 gas. So we are very competitive on that level.
Yeah, interesting. I know one of the other topics I was speaking earlier with Seb was, I think it was, I can't remember how long ago it was, but I think there was this article written by Vitalik where he made the suggestion that Uniswap could function as an oracle, quite efficient oracle. What's your view on that? Kind of like this Dex versus oracle, and where you see advantages and disadvantages between the two, and what's your outlook on that subject?
Yeah, totally. So I'm really impressed by the amazing job, especially by the Uniswap v3 on the TWAPs and how they optimized the whole solution. So it's a great step forward. I'm a bit cautious always into trusting a single source of truth. So even if there's like a lot of liquidity in Uniswap, is still a single service. So anything can go wrong with a single service. So always is better to have some backup, some redundancy in terms of the data sources. So that's my concern. Yeah, we are actually, as you know, all of the data has been persisted to Arweave. And at the moment, we got almost like a 1 full year of data records that are publicly available for anyone. And we recently hired a person who is dedicated to crunch those data and actually to answer questions that I got in my mind for a very long time. Like, are we there yet? Are the Dex, let's say, the data quality from Dexes comparable to the biggest off-chain players, and what are the differences, etc., to try to find the patterns? I'd love to share the insight with you guys.
Actually, that what you're discussing, I find very interesting in that discussion, which is, so if you compare the nature of, let's say, like how a Dex works, there tends to be a lot of arbitrage to find what and to find a spot price between, but you're always kind of like arbitraging back and forth or counterbalancing the trades that are being made, I should say. Whereas an order book, when you place an order and you're buying something at a specific price, right? So the price mechanisms between the two types of exchanges, there seems to be a dependency going one way, and that is saying that like those who are arbitraging between a DEX may be referencing centralized exchanges for spot price. This is just kind of like loose thinking, but what you were kind of talking about this. What are your thoughts more about that? Like, do you find that that this phenomena is probably expected early on, but as DEXs become more utilized and more efficient, that maybe this this gap between the two may kind of go away?
Yes, it's definitely like having larger liquidity on a DEX and a
They become more
greater volume.
efficient.
We help the actually it's a very interesting topic, like how the V3 actually like manage the volatility of price. So on one hand, it's like really great to utilize the liquidity. On the other, if you get out of this supported range, you really risk like a very sudden drop. So that's also like super interesting, like how it will play out in the terms of the data stability. And obviously there's also like an answered question, like how to actually utilize these TWAPs from Uniswap. What's the proper range? Because if it's like too short, then keeping in mind that it's a DEX and it could be connected to a transaction, you risk into really smart arbitrage. But if it's too long, then you lose the accuracy of price data, especially important from the leverage. So I think we've been discussing a few teams what's the best approach to that, and I don't think that anyone has gotten an answer.
I think it's like because I'm a big fan of V3, Uniswap V3. It seems to me to treat trading on V3 sort of like a limit order, and rather where a limit order would immediately sell or buy, based on your position that you put in, it's more along a curve, right? So you're selling along a curve until you're sold out of the range. I think what could make V3 better is faster confirmation times, being able to swap in and out. I think one of the things that makes it unusable is not being able to get your order in or to shift the range if you need to, and paying high amounts of gas to do that. So I don't know, maybe on a different platform that has a faster execution, it might be more practical to use. But I think one of the big drawbacks, like you said, is like, if your range is not perfectly in some kind of action, you're gonna lose out. So
or from a global point, if the range is like too thin, then definitely
if it's too thin,
market as an oracle.
Sometimes you see like a very long spike, like somebody's just trying to like liquidate their entire position, right? And it's like sometimes if the range bounces in between that line, they're just they're sweeping a large amount of fees. It's really interesting.
I agree. So probably there's always like a trade-off between like super, let's say, efficient price discovery, which you should have the same liquidity for every price range, and profitability of liquidity providers. So I don't think it could be like perfectly matched.
I'd like to talk a little bit about the design, the like RedStone's design, and specifically like what the tech stack looks like. Can you describe like what that is, and so who are the data providers and how are they incentivized to provide good data? Like what does that look like from sort of like a design perspective?
Of course. So a data provider is actually a node that publish kind of we call it manifesto, but it's kind of a publicly available SLA, like what kind of sources are going to be utilized, what kind of aggregation methodology to be used, whether it's like a median, TWAP, or anything like that. And also what's like refresh interval, and then it's being accountable according to that. It's kept accountable according to that manifesto by users who consume the data. Also, the data provider specify the pricing policy, and at the moment, obviously, we use the easiest one as a subscription, but we are going to experiment with a pay-as-you-go pricing model, and could be charged per single price feed. That could be interesting for the space. And yeah, so that's on the revenue side, and also on the let's say guarantee side. The data provider, in case if the price is not prepared according to that manifesto, maybe it wasn't being delivered, or data provider cannot defend that it was taken from given sources and aggregated properly, then a data provider could be slashed and lose part of the collateral, which is strongly required for a provider. So that's kind of an insurance mechanism. As I mentioned, the prices that's also like super interesting. Like, how can you take a price from a data provider and pass it to a target blockchain, as we do not push it to the storage. So we've been thinking a lot how to secure this relayer part. So it's very similar to like a 0x relayer, but we used a lot of redundancy mechanism. So we got our own light nodes, like super dump nodes, just taking data and copying data and making sure that the signatures are correct. We also integrated with Streamer, which is a super interesting decentralized PubSub mechanism, having like few thousand nodes. So it's really not easy to DDoS the service. Especially, it's like in general, it's not easy to DDoS a PubSub mechanism. And yeah, we also got our own caching servers, which are much more heavy, but can handle tons of traffic. So we got these different levels to securely transfer data. And obviously we got Arweave as a permanent archive. We serve two purposes. First, you can have a full track of record of any data provider if you're doing due diligence and choosing the best one. So there's the highest level of transparency, and also like super important for us to have a regular heartbeat on the activity of oracles. So to detect any issues as early as possible. So if the oracles are forced to provide the information at every interval, then we can detect any issues and quite early.
So on the guarantees side, you said that the data providers they submit a bond and they can be slashed. Is it an opportunistic model where someone can come and provide a proof that the data wasn't provided correctly, or that there are discrepancies in the data, or is it another sort of what's the consensus model, I guess, around like providing guarantees?
Yes. So currently, we use.
And is it one follow up?
Sure.
Is this in an Ethereum contract, or is
no,
it like
no? So
okay.
It's actually the SmartWeave contract based on Arweave. We call it dispute resolution mechanism, and in the current form, when it's not live used, but at the level that we are in, we got the very democratic mechanism. Like you start a dispute, then you can have a counter argument. Then, in case of one of the parties not happy with the outcome, it could be escalated, and at the very extreme case, the whole network needs to vote who was right. So it's like still very manual. We are experimenting with automatic proofs, but it will probably come later.
Okay. And so the data providers will set their bond in what currency? Is it like R? Is it Arweave?
So the bond is requested to be set in our token, but the token is not launched yet. So
okay, yeah, I think
so
that's
that will
the
be
piece that was missing.
the main purpose of the token.
Okay, so the data providers put up a bond. Then there's a dispute mechanism that allows a counterparty to dispute the validity of data. And then there's a process through which there's a decision that's made on the validity of that data. And then the bond, I suppose, is burned. It appears to me that there might be an attack mechanism here where someone could, if they want to sabotage a data provider, just create many disputes on a data feed. Is there like also something at stake for one who is making a dispute claim, like a bond that they also have to put up?
Yeah, definitely. So being a whistleblower is not, let's say, obviously we don't want the protocol to be spammed with the false alerts. So any whistleblower, we need to provide a minimum stake on his side to prevent like raising false alarm. Yeah, so like a typical mechanism of protection.
I guess I kind of want to understand a little bit more of this Arweave smart contract system. So I think you guys are maybe the two people that I know who understand it the most. And I some people have tried to explain it to me, but it just hasn't. I haven't quite understood. So hopefully you guys can fix that. Like how does it work? Like, I mean, how does it work, and how is it different from, say, a contract on Ethereum or like a CosmWasm contract on Cosmos, which I think most people are more familiar with those two designs.
Which one do you want to start? Because I was like monopolizing.
Well, I think. I guess to come in kind of a high level. So I think if you describe how say an Ethereum smart contract works, you write code, it's converted in some kind of bytecode, and then this is executed in what we call the Ethereum virtual machine, which runs on all the miners, and all the miners execute this code, and the execution of that code is recorded on a blockchain. And so then future miners can then pick up, confirm, and verify and continue. Right. So a lot of the execution is happening within the miners and stored on chain. With Arweave, since we have this permanent hard drive, we could write quite a bit of data to it and then deal with the verification and processing later. And so the way that the SmartWeave contract works, from my understanding, and Jacob can probably go much detail than I can. Basically, we store the state and the contract on Arweave, and the execution and verification of those contracts are pushed onto the client. So I believe they call it lazy execution. Jacob, do you remember what the lazy execution? So basically, you're only storing state and contracts on chain, and then you execute and verify off chain on the client. And I think that's where we found at Akord. I mean, we use RedStone's smart contract system for what we're doing. And while that in theory works, there's quite a bit of infrastructure that has to be put in place to make it practical and being able to be able to use it in production. And so I think that's probably a good place for Jacob to start, is kind of go into detail about the RedStone smart contracts and how you've implemented and improved the SmartWeave contract system. Because basically you guys rewrote it from scratch, right? If I understand.
Yeah, so I think that the credit for the idea has to go to Sam, the Arweave founder, who prototyped the first version.
Yeah,
it was like super interesting. So yeah, so at the first glance, definitely a lot of people think that it's a scam, it will never work, etc., because it's so different than the current design part of the smart contract space. But if you look deeper, it's actually like super smart to detach the two phases of the data storage and the data execution. So if you get a system when you can actually achieve a consensus on the pure transactions without executing them, so if you can order and persist transactions and with the assumption of the deterministic executions that the same set of transactions in the same order will always get you to the same result, then you should be able to detach these two phases. So have a very cheap consensus on the ordering and storage of transaction, and then delegate the execution to another service. I think it's also getting popular in the current rollup patterns when they try to compress the transaction, put a proof on chain, and then move execution to the layer 2 network. So stuff like that is getting more and more popular, and that's also the reason why solutions like Celestia are popping up, which is a chain dedicated for data availability, when you can actually have this transaction storage and then connect it to different execution environments. And as Richard mentioned, yeah, in theory, it looks really, really cool. But if you get to this, let's say, implementation part, then there could be a lot of really interesting challenges, like actually how to make it fast and efficient, how to deal with the data access, the necessary indexing, how to sequence the transaction, put ordering, how just to make it, let's say, efficient enough to be production ready. Because theoretically it's a fascinating concept, but then if you delegate all of the execution, you need to also think like who will be executing the code, whether it could be fast if you need to re-execute like all of the historical transactions, how to efficiently cache the execution, how can you take snapshots of states, not to rework the full history, etc. So there are a lot of super interesting challenges, and we try to solve it one after another, still being able to offer the solution to other projects.
So maybe just to sum up here. So with a sort of EVM design contract, we have the execution that is performed by minders. The state transitions themselves are stored on the chain, in addition to into the data. And so in order to reconstruct and to verify all the transactions, we have to go through the state transitions to make sure that all those are correct.
Right.
Whereas with an Arweave contract, the contract and the state are stored on chain. And what you do is you say, okay, this is the contract, this is what was run, this is the resulting state. And so you have to rerun. You don't have the state transitions on the chain, but you have the state. And so you could technically just run a contract on your client locally, and then store that on store the resulting state on the chain.
Yeah. So in other words, you got all of the inputs on chain, and you can always re-evaluate the state to get an output, but it's like totally detached. So the consensus mechanism doesn't require you to execute transaction, and therefore it could be much more scalable. So yeah.
So the benefits that we get are that you don't have to store the state transition on chain, which I guess is what takes up a lot of space. You just have to put the contract and then the inputs and the outputs. Is that right?
Yeah, exactly. So if you imagine a transaction that is like really resource heavy, like data processing transaction, which is currently impossible in any EVM compatible chain, because it can slow down the whole, let's say, other transactions, so it will get out of the block limit, and therefore if you detach the execution and you simply store an input as an order to be executed later on, you can fit a really heavy transactions and then try to execute that in, let's say, dedicated network whenever you actually need that state.
Okay. And who like if the execution is being done by a single client, who's verifying these state transitions? And yeah, like how does that work in a practical sense?
Yes, sure. So you got the code, you got the inputs, And if you are an honest user, you always get to the correct result. And so anyone can let's say verify the end state. Anyone has all of the necessary ingredients to verify the end state.
And is this
Obviously,
quick
it's
to verify? Like, can my client just look at the
no,
chain and like
no.
verify an entire
No,
contract?
yeah.
And
At the moment, it's in the original form. It's not quick to verify. That's why, and yeah, it's let's say honestly, it's a naive approach to require every end user to recreate the state. That's why we are building a delegated execution networks. This is a complex structure that we are putting together that should help you to first get answer faster, second leverage the dedicated node to evaluate the state and to verify the result much quicker. So yeah, like having like a snapshot rollups out of the networks that should be confirmed by the major of rather like with a fraud proofs that should be refused by the majority, so the client can trust snapshot and only reevaluate the smaller part that should be possible for, let's say, end users.
okay, so is this so? And then what are the trade-offs in terms of like, can you still achieve the same type of composability as you can on an EVM chain, or is that more, does that make it more complicated?
It makes it much more complicated. I think you nailed that trade-off perfectly
Yep.
well. So yeah, we are working on cross-contract calls. They are much harder to implement, and they require some innovative thinking. It's possible, but it's definitely I'm not going to refuse the statement that in terms of a composability, we won't be as composable as EVM or networks like Solana when they get a very single state accessible to others. But on the other hand, we are much more scalable and we allow like really heavy computation that won't fit in a block. So that's the spectrum. You get a lot of flexibility, you get a lot of scalability, but then the composability is much harder, but still in our view possible, and we do cross-contract calls, although they are much more expensive to evaluate.
Also, by its very nature, it's parallel. It's executions in parallel, right? So you're pushing it to the client. Yeah, and like Jacob was saying, you can have some contracts that could be very computationally expensive. Run that in parallel. There's no impact on the overall system.
Yeah. So are there use cases that are kind of geared towards this type of design pattern,
Yeah.
or is this something that y'all think is going to be generalized?
Well, if I may, Jacob, I think from Akord's perspective, it was a perfect match for what we were doing. So maybe just to talk 2 minutes about that. So we originally built Akord with a particular blockchain in mind, but the blockchain didn't exist. So we built this kind of protocol that we ran in our internal blockchain, just waiting for the blockchain to arrive. And luckily, it was Arweave. And so basically, everything that we do in Akord, whether it be creating a new vault, inviting people to the vault or members to the vault, uploading files, revisions to the files, posting notes, and things like that, all of these kinds of activities, which happen encrypted in a vault. Each action is encapsulated as a transaction on Arweave. And so what we're able to do is just map our protocol and transaction set directly over to SmartWeave's contract. And that allowed us to just port things very quickly. And essentially what we're trying to create is this like kind of like audit trail of each of the states in time for that vault, right? And those
and bears pointing out that you guys are building a sort of decentralized Dropbox,
right?
Exactly. With versioning, like document versioning, traceability,
yeah, and notes and editing and messaging and collaboration features, all of that. So it's very interactive. And where I was getting at was like, so we're doing a lot of heavy encryption and decryption. So that is one of the examples where we can offload that onto the client. It has to be on the client if you want end-to-end encryption, and then just send over bits and then record those as state transactions in the protocol, right? In Arweave. And so that worked out really well for us. We were able to deploy our protocol, within just a few weeks. So it was pretty quick for us. Where we ran into a hurdle we ran into obstacles where Arweave started getting very saturated. The gateways were saturated. We couldn't commit transactions. And then we were also trying to address some of the remote calls and stuff like that, which RedStone was able to address. And so, yeah, I think, I'll let Jacob take it from here. I think that's kind of a short story for us.
Yeah, it's a good, amazing example. Definitely something we've been thinking of, and it's great that it's been validated by Richard and Akord.
Yeah.
And so there is the data processing logic when you need to have a lot of access to the basic storage, which probably is impossible into chains like EVM based chains, but also if you'd like to think of any application that actually mix some storage and logic, like native NFT processing, when you do really some manipulation with the true NFTs instead of passing ownership of hashes, or if you do any transformation of the content, like
atomic NFTs.
Yeah, also a company that uses us and that's processing the digital recording songs, pianity. It's super interesting. So there's also heavy data processing, also probably from the metaverse ecosystem, when there is the projects are forced to process heavy loads of data, rendering information, etc. That could be quite an interesting angle for us.
Yeah.
And any kind of either heavy computation or a lot of input output requests. That's a good match. And as I mentioned, as a trade-off, the composability could be limited.
Yeah, there's a couple other things I'd like to mention. You mentioned the NFTs. I believe they're called atomic NFTs on Arweave. And so
what's an atomic NFT?
Yeah. Okay. So earlier on we talked about how with NFTs you've got the contract, essentially the token, stored on one chain, and then you have the data, the graphic, the JPEG or whatever it may be, stored somewhere else, and in this case Arweave. So you've got you've got the NFT split into two parts, token and data. And so what Arweave unlocked was, okay, we can not only store the data, but we can also write the contract for the token, and they're inseparable on the chain.
Okay.
Right.
Yeah,
so that's what it calls atomic NFTs. So it's just one complete unit. And then there are some other projects in the ecosystem that allow you to bridge those tokens. So you can have the token live on Arweave and then trade it on Solana or Ethereum, something like that, right? Basically wrapping it somehow. So that's very interesting. There was a second, there was another use case that was really interesting. I'll come back to this later once I can remember.
Yeah. Okay. No, that makes I think I understand a little bit better now that so how does this fit into the cross-chain thesis? Because this is one of the things we were talking about when we were at dinner the other night. And, I really want to discuss here, so with regards to RedStone and the oracles that you provide, the data you provide, how does that fit into the interoperability thesis that, say, we have on Cosmos? And I guess more broadly, where does this fit also in this modular blockchain idea, this idea that's pushed by project like Celestia, or we're hoping to see in Ethereum too? Can you kind of unpack all of that and maybe make it a little bit clearer, because it's still a bit nebulous for me?
Sure. So let's start with the latest, the modular blockchain design. So when you start building our smart contract infrastructure, then definitely having to work on the storage layer, secure storage layer, and then the secure consensus layer and the data availability proofs, all of that from the beginning as a which is often called like a monolith. If you'd like to create the protocol starting literally from scratch, it will like take us probably like 5 to 10 years to get it secure. But actually, there's like a pretty good and solid storage network called Arweave. Also, like Celestia is entering this space, which could be like a really good composable component, because Celestia focus on a short term, very strong availability proofs, when Arweave is amazing in the long-term data storage and having a full history of a chain. And then obviously we'll be using Cosmos for the interconnectivity of our execution networks, so they can be kept accountable with their stake, and that the correctness of the computation could be verified and roll up to that network. So we use a major pieces of technology like Arweave, Cosmos, probably Celestia, and try to glue them together, adding our own magic sauce, which is the economic model and the ability to target the solution to a given use case, which in our terms are data processing, or let's say the flexible smart contract execution. So in this modular world, you try to experiment using all of these amazing tools that were already developed and try to creatively join them together to create a blockchain with a unique features. So that's
Can you elaborate a little bit on this uses the Cosmos SDK, and because I'm not quite sure I understand like how you guys are using it. Are you using IBC or
no? So we I mentioned briefly, like it's not feasible to expect all of the end users to fully re-execute the transaction. So there is a need for dedicated professional evaluators that can form networks, and to keep them accountable and incentivize them to provide correct answers, there need to be a mechanism where they can usually like leave a collateral, provide a stake that could be slash, etc. So there is a need for a network to manage that coordination, and for that we'll be using Cosmos. So like a typical Cosmos with probably ABCI extension or the new ++ version.
Okay, understood. Yeah. All right. So you'll be making use of the Cosmos SDK to build a Cosmos chain that will enforce this sort of incentive mechanism to provide data. Okay. So are you planning to launch this as a standalone Cosmos chain with your own validator set, or will you be using like interchain security? Or
so we are going to start from the standalone chain, and we see what kind of an extra value can we get from the interoperability with the other Cosmos chains.
Okay, interesting. Yeah, because I mean, at a minimum, like I think like being able to like have your token as like an IBC token, like tradable on Dexes like Osmosis and stuff, is kind of interesting. But I don't know like what other benefits would come from having this chain be interoperable with the rest of the Cosmos ecosystem.
I don't know, maybe they can delegate like data storage logic to asset. I think this is again amazing. Let's say way to explore the potential synergies.
Yeah. And then so okay, so I think I'm getting a clearer picture here where Celestia is really strong with short-term data availability, and I haven't really dove deep into Celestia yet. Like that's an episode that I want to do soon. You guys are better suited for long-term data availability because you're using Arweave as the data layer, and so is this something that can be used in coordination with Celestia, or is it for two different types of use cases? Is it like two different types of use cases, or is it like you execute on Celestia and then like back up on SmartWeave, or are we looking at like different types of applications here?
Yeah, so I think they're very complementary, and we're thinking about the solution like Celestia to provide a really strong data availability guarantees, especially before the transaction could be properly seeded on the Arweave network. And yeah, we're like super happy that the guys from Celestia are implementing that. We recently visited the modular summit, and definitely we are going to be like early adopters testing out the solution. Unfortunately, it's not like production ready yet, but I think there's amazing potential to connect it to side of a continuum of data storage to, because Celestia incentivize the data availability in the short period of time, while Arweave is some amazing of the permanent storage guarantee, but not as quick as Celestia to give the data availability proofs. And this is an amazing piece of technology with the erasure proofs. Really cool stuff.
Richard, you're muted.
Sorry about that. Yeah, so I believe the saying is like it's permanence over performance is what Arweave is tuned for. Yeah. One of the other things that it just came back to my mind when we're talking about use cases with Arweave, I think there's something interesting to say here. So, when we have data on chain, when we have the application, because the application itself is data files that can be stored on chain as well, and then you have a token with logic and contracts and things like that. So you basically have data, application, and business model all running on the same chain. And I think that is like where Web3 can take us. Like this whole idea that a business model and the data and the app, everything is together on chain and it's available for as long as that blockchain is available. That starts to become something very interesting. And for what we're doing at Akord, there's this model that I believe it was Sam. I may be mistaken, but I believe it was Sam. He introduced what was called profit sharing tokens. And so this is where you can build your application and then the business model that you pay. So in this kind of model, you only pay for what you use, whereas a Web 2.0 model, you have a subscription fee and you pay $20 a month or something like this, or $40 a month. With a profit sharing token model, you only pay for what transactions you commit, right? So if I create a vault, I pay. If I add people to that vault, I pay. And what that means is that each transaction, the fee that you pay basically has three components. One component is a transaction fee. So you pay the miners to confirm the transaction. The second component is the storage endowment. So you, depending on how much data is included with your transaction, you pay upfront for that storage on Arweave, and that money the tokens go to a crypto endowment that are projected to grow over time. And then as storage costs decrease over time, the difference between the two is the incentive for miners to store the data. And then the third component of what you're paying for is you're paying a community fee. And so if you have a protocol with token holders behind the protocol, that community fee is paid back to the token holders. So now you've got this like incredible potential built up in a flywheel, right? So as people start using the application, they start using the protocol, they're creating transactions. Those transactions are generating fees. The fees are being paid back to the miners, to the storage endowment, and to the token holders. And then this just kind of like picks up momentum over time. And that's an incredibly powerful model. Not too many people know about it. It's a very new kind of like interesting idea within the Arweave community. But I think it's one of the ideas in that community that has the most potential.
Yeah, I know you've been telling me about this model for a while, and I know how bullish you are on.
It's the dream. It's the dream,
yeah.
Right? Data, app, and business all on one chain, like fully integrated. I think we'll see a lot of that develop into the future, especially as Web3 becomes more adopted. User ownership of data. You're owning part of what you're already using, and so. If you look at the incentive structures of Web 2.0, the incentive structures are set basically for the investors of the Web2 project. Money goes into the team produces product gets used by customers, but the data starts to become very valuable. So you look at Facebook, you look at a lot of social media, it becomes very controversial, and then you have like, users are now locked in. Maybe they need this much of your product, but they still have to pay the same amount as everyone else, right? So everything's really incentivized towards those who hold data and those who are investing in services to build around data. With the Web3 model, where data, application, business model are all on chain, people own tokens, and that's their like stake in the protocol. They're using the same protocol that they have a stake in. Suddenly, the incentive structures are all lined up between the developers, the investors, and the users of a system. And so that's what I'm trying to describe is in a flywheel kind of analogy, that once these incentive structures become all aligned, like really interesting things can happen. So I guess there's a lot to say about that. We can continue talking about that for another hour.
Yeah, we'll have to do another episode about the economics of Arweave, because it's something you keep telling me about, and I keep trying to wrap my head around, and other friends of ours are also trying to wrap their head around, and you seem to be very, very keen on this vision, and I think you're probably right about it. It's too early for us to even comprehend what's going on. But yeah, thanks to both of you for doing this with me and diving deep into all this stuff.
Thanks for having us.
Yeah, no problem. Jakub, where can people learn more about RedStone, and is there a call to action here?
Yeah, sure. So invite everyone to our website, redstone.finance, or you can find us on the Twitter. There's a link to our Discord. Come ask questions. We are like super open. We recently launched an initiative called Redstone Academy and try to teach how to implement the contract starting from the very beginning. So even if you're from the web 2.0 and not familiar with all of these crazy blockchain terms, we try to take you by hand and introduce to all of that step by step, showing the tools, how to test your code, how to deploy in the very safe environment, how to just step by step start building on Arweave using our contracts and exploring the space. So yeah, we are really open and try to help you to implement even the most craziest ideas there.
Cool. And Rich, maybe take this opportunity to shill Akord a little bit and what you guys are doing.
Well, we're happy just to talk about, I think on this show about our partnership with RedStone. We've published some articles on the blog talking about what we're doing together. And a lot of this will be coming open source in the near future, weeks, if not next month or so. So if I were to shill Akord, we're here to help protect the data that you care about the most. And we're going to help you take care of that data until the apocalypse. So that's our goal.
And the website is Akord. It's
Akord.com.
Akord.
Yeah. Right.
And I've used Akord. I like it. I used it for we're using it to like share legal documents and stuff like that. And it's like this is like little vault sort of. It feels like a Signal chat, but where you can also, drop documents and things like that. So I think it's has a lot of promise.
Well, we hope to deliver the developer tools this summer. So we'll be very interested. One of the areas that we're interested most in taking it is to provide DAO tooling. So providing long-term storage for your DAOs, storing your votes, your documents, and things like that to help provide the DAO members the information and data that they need over a long period of time, potentially multi-generational. That is, yeah.
That's cool. Feels like it's your life's work. I've known you for long enough to know that like this is something you've been working on for a long time in various iterations. But yeah, feels very much like this is something that you like really want to achieve, like being able to preserve data, have integrity of data and privacy around data.
Yeah.
So
it's
cool, guys. Well,
thank you.
Yeah, thanks again, and have a great rest of your day or evening.
All right, you too.
Thank you, Sebastian.
Ciao.
It's great to be there.